Mary Peters. I went to a couple of the special topic physics lectures this semester, and my favorite was Tom Murphy's lecture on the power of physics estimation. In his lecture, he emphasized the power of using estimation to solve complex problems. For the first part of his lecture, he used estimation to prove that global warming is real. Then, in the second part of his lecture, he used physics and estimation to compare different energy processes. He emphasized that we are going to experience a major energy crisis when fossil fuels run out, because other alternative processes don't even compare to using gasoline. A Fermi problem is a multi-step problem that can be solved in a variety of ways, and whose solution requires the estimation of key pieces of information. Here's the example Fermi problem that Murphy opened his lecture with. We tried to determine how many kids have milk streaming out of their noses at this very moment. You can see with this problem that solving Fermi problems often involves dimensional analysis and estimation. So first, we took the total number of people living in the world, which is 7 billion people, and then we estimated the life expectancy to be about 60 years. Then we considered what the vulnerable age is for this to actually happen, and we decided that that was about between the ages of 4 and 10, which is 10% of your life, which then means that it's a 700 million people are at risk right now. However, when we thought about how many people have actually had this experience before, it was only about half of the class. So we then decided that there's only probably about 350 million people at risk right now. And then we had to determine how many times have people actually had this happen, and for most people it was only a once-in-a-lifetime event, and it lasted about 10 seconds. So using all of this, we then determined that there's probably about 20 people that are laughing so hard right now that milk is streaming out of their noses. Here's an example of one of the slides from Murphy's presentation, where he used estimation to calculate how much land we would need to replace oil with corn ethanol, which is another alternative energy source. And this map shows the great deal of land that it would take. And it's a great example of how great oil really is and the problems that we will face trying to find alternative energy sources that can compare. This topic interested me because it was applying physics to solve real-world problems. I'm planning on pursuing a career in medical physics, where I would use radiation physics to help cure cancer. Lastly, I would like to connect the topic of this lecture with a project that I worked on last year. Me and a group of my dorm mates estimated the amount of water used in our dorm per month. We were surprisingly close to the actual value. We estimated how much water is used in each water-consuming device. So we broke it down into like the toilet, the shower, the water fountain, the ice machine, etc. And we then estimated the water use per person per day and multiplied the total number of days in a month and the total number of people living in our dorm. And so I really loved this project because it was an introduction of a new way of thinking about real-world problems, and I think that it's very applicable to future research and also just like different ways of approaching real-world problems. Thank you.